Welcome, everyone. Thank you for joining us for today's webinar. My colleagues and I are excited to introduce Signet, an open source contract testing framework for microservices. My name is Zach, and I'm joined today by Michael, Hernando, and Eric. The four of us collaborated remotely over the last several months in order to create Signet. Here's the roadmap for today's presentation. We'll begin by breaking down the problem domain that eventually led us to build Signet. First, we'll provide context for what microservices are. Then we will talk about why they are challenging to test. After that, we will introduce contract testing and walk through the existing solutions in the space. Finally, we'll discuss Signet's approach to these problems and talk about the trade-offs and design decisions that we considered while building it. We'll also leave a few minutes at the end for Q&A. Let's start by talking about the difference between monolith and microservice architectures. In a monolith, all of the server-side logic is deployed together as a single unit. In this example, there are three business domains: shopping cart, users, and payments. In a monolith, each of these domains is modeled by a programming construct, in this case, a Ruby class. The objects which are instantiated from these classes run in a single process, and they interact with each other through in-memory method calls. Oops. Somehow I skipped all the way to the end. Sorry about that. Give me one moment. All right, so we've discussed monoliths. We've discussed that each business domain runs as a programming construct in a single process. In a microservice architecture, each business domain is modeled by a standalone service that can be deployed independently. Services interact with each other by passing messages over the network. Here, the shopping cart service consumes the functionality of the user service by making an API call over HTTP. Microservices make it easier for many engineers to work on the same application. However, they also require a more complex infrastructure than a monolith. If a business is going to choose microservices instead of a monolith, there are two characteristics they will want to maximize. The first one is limited ownership. Limited ownership means that each team of engineers only needs to know how their own services are implemented. If the shopping cart service needs to access the functionality of the payment service, the shopping cart team only needs to know how to use the payment service's API. Everything else about the payment service is abstracted away. Limiting the scope of the shopping cart team makes it easier for them to build new features quickly. The second thing that microservices should maximize is independent deployability. This is where services are loosely coupled in such a way that any of them can be updated and redeployed at any time. Let's say that the user service team wants to add a new feature. When the feature is finished, they can deploy the new version of user service without coordinating with any other teams. As long as the user service API remains backwards compatible, the other services don't even need to know that the user service was updated. For many businesses, limited ownership and independent deployability are worth the extra complexity that comes with microservices. However, even if the design of the application supports these benefits, their effect can be diminished during the process of testing. In order to understand why this is the case, let's take a brief detour and talk about automated software testing in general. Automated software tests can be classified using a pyramid. The foundation of the pyramid is a large number of lightweight unit tests. A unit test verifies that an individual component of the system works in isolation. Above unit tests are integration tests, where multiple components of the system are tested together. At the top of the pyramid are end-to-end tests, where all of the components are put together and the app is tested as if it was released in production. Here's the main takeaway from this diagram. The tests at the top of the pyramid give the most confidence in the quality of the app, but they are also more expensive and time-consuming than tests that are lower on the pyramid. This realization leads many companies to sequence their tests in a particular order. Here's an example of how tests are often sequenced in a CI/CD pipeline. CI/CD refers to continuous integration, continuous delivery. At a high level, it is the series of steps that new software must go through before being released to production. Unit tests typically come first because they provide the quickest feedback when a bug is introduced. As software progresses through the pipeline, the scope of each test increases, along with our confidence in the quality of the software. In addition to the sequence of the tests, the overall length of CI/CD matters as well. A long CI/CD pipeline delays the release of new updates and also takes longer to notify developers if their changes broke something. For monoliths, it is common for integration and end-to-end tests to be run before every new deployment. However, the story is different for microservices. There are a number of difficulties with running integration and end-to-end tests every time a new version of a service is being deployed. Let's examine integration tests first. Suppose that the shopping cart team updates their service, and they want to test that the new version still integrates with the payment service. In order to test the two services together, the shopping cart team needs to know a few things about the payment service: how to set up any stateful data that the payment service needs, how to configure and deploy the payment service, how to set up any external dependencies that the payment service requires, and finally, they need to know which version of the payment service is currently released. Do you see the problem here? Limited ownership means that the shopping cart team should not need to know any of these details about the payment service. One way to get around this problem is to use a service test. With a service test, the shopping cart team uses a test double instead of the real payment service. The test double simply returns a canned response when a request is made to it. Using a service test instead of an integration test saves the shopping cart team from having to run the actual payment service. However, they still need to keep the payments test double up to date with the real payment service, at least the way it behaves. A contract test can help with this, but before we get there, we need to examine a few more problems with testing microservices, this time related to end-to-end testing. The first challenge with end-to-end tests is that they are difficult to build and expensive to run. End-to-end tests try to simulate production conditions as closely as possible. In many cases, this requires duplicating the entire application in a dedicated staging environment. Not only is this expensive, but it can also be very challenging to accomplish for applications with a large number of services. Another challenge with end-to-end tests is that they are slow. They are often used to exercise consecutive user interactions as they would occur in production. For example, a test might validate that a user can sign up for an account, then log into that account, and finally try to buy something. These tests are especially slow for microservices because each test may result in several API calls between services. The third difficulty with end-to-end tests is that they tend to be flaky. A flaky test is one that occasionally fails, even when there is nothing wrong with the code being tested. A classic indicator of this is when running the same test over and over yields different results. Flakiness can occur because of network faults, third-party services being unavailable, and application state not being set up or torn down correctly between tests. To recap, integration and end-to-end tests are challenging for microservices, especially when they are used in every service's CI/CD pipeline. These tests don't always conform to the limited ownership of teams. They're expensive, they're relatively slow, and they have a tendency to be flaky. However, we still need these tests because they provide a lot of confidence in the overall quality of the app. How do microservices address this dilemma? Well, a common solution is to reduce the number of integration and end-to-end tests that are needed, and if possible, move the rest of them outside of CI/CD. In their place, other forms of testing can be used along with progressive delivery techniques. These make CI/CD faster, while still providing a sufficient level of confidence in the quality of the software. Ideally, any integration and end-to-end tests that remain can be run on a schedule that does not obstruct the rapid release cycles of services. At this point, we have discussed why microservices require a unique approach to testing. We have also briefly touched on service tests, something that will come up later as we discuss the design of Signet. For now, I'll hand it over to Michael to take a closer look at contract testing in particular.
All right, thank you, Zach. Hi, everyone. Let's jump right in. So, what is a contract test? To recap, a traditional integration test spins up both services and verifies that they properly work together. Service tests try to narrow the test scope by replacing the external service with a test double. A contract test is different. It interrogates each service in isolation to see if the two interfaces are compatible with each other. It has a much narrower scope and only tests the interface between the two services. So contract tests get their name from a document known as a contract that formally describes the interactions between the services. The contract does this by enumerating the HTTP requests and responses that each service expects to send and receive. In a basic form of contract testing, a tool reads the contract and replays the requests against a live service. The actual responses are then compared to the expectations described in the contract, and the test passes or fails depending on whether they match. A failure here indicates that the services will not integrate together. Now, I'm sure this is all very stimulating, but why would we want this, right? The first reason is speed. Contract tests are much faster and less resource intensive than traditional integration tests. This lets developers identify bugs much earlier in the process, saving time and accelerating the feedback loop. Yes. Just speaking for my own sanity, I would much rather fail a test after 30 seconds of local testing than 30 minutes of a deployed end-to-end test before having to start over. Next, contract tests run in isolation with the service being tested, saving the burden of having to deploy multiple services together for testing. This helps us with the independent deployability that Zach described. Last, specificity. Because each request and response is described in the contract, a failing test can report exactly which messages are missing or malformed. So clearly you're now hooked, but contract tests do have their limitations. The first is that they should supplement, not replace end-to-end tests. This is because they have a more narrow focus to test the compatibility of the interfaces and catch breaking changes quickly. Another trade-off to consider is that implementing contract testing may require writing many new tests. Until there's sufficient coverage of the interface, you can't be confident that you're going to catch those breaking changes. So great, now that we've got the fine print, we're ready to look at some common approaches to contract testing. But first, let's define a couple terms. So when we're talking about an integration of two services, we often find it useful to classify one of them as a consumer and the other as a provider. So a consumer service depends on functionality or data from another service, which is of course the provider. And it's worth noting that these labels only make sense in the context of a particular integration, right? A service can be the consumer in one pairing, and then it can turn around and be the provider in another. So now that we're armed with our new vocab, let's take a look at those approaches. All right, first up is the consumer-driven model, where the contract represents how the consumer is currently implemented. The nice thing about this one is that the contract describes exactly which parts of the API are being used by the consumer. The main drawback is that it doesn't deliver independent deployability. The consumer team still has to wait for the provider team to pull down the contract, spin up their service, and verify compatibility. Up next, we have the provider-driven model, which is nearly the reverse of the consumer-driven. not too surprising. Here, the contract represents the current implementation of the provider service, often in the form of an API spec. And you'll often hear it, called that when we're talking about it, from the provider perspective. So the main benefit here is that it gives the provider team control over what the integration is going to look like. And this might be a better fit if the provider has a large number of consumers, which would make it really impractical, to negotiate the API individually with them. Okay, last but not least, spec-driven, our favorite. Here, the API spec is defined separately from either service's implementation, ideally by having the teams agree to it in advance. This makes it a natural fit for spec-first API design, which is a development practice where the team decides on a spec before writing the code, instead of documenting it after the fact. The value here is that it allows each service to be developed in parallel and tested against the spec along the way, without having to wait for a completed implementation of the other service. Awesome. Okay, we're going to wrap up this section with some thoughts on what to consider when choosing a contract testing solution and how these considerations led us to create Signet. So the first thing to think about is which of the testing approaches, does the solution support? Whether consumer-driven, provider-driven, or spec-driven. And this is a really important first step because it defines the fundamental developer workflow going forward. For us, independent deployability was a priority, so we eventually narrowed our search to Pactflow and Specmatic, since these were the only prominent options that offer a spec-driven approach. The next big one is the ease of adoption. And what we're talking about here is the startup cost. The big one being whether we could use existing service tests to generate the contracts instead of having to write a ton of new tests just to, get up and running. So this is where Specmatic really shines because it offers a way to generate the contracts by automatically recording the interactions between the consumer and provider services. It's very convenient. In comparison, Pactflow requires you to write new tests using a language-specific client library. They provide a number of those, and that's about as fun as it sounds. Next up is whether the framework or solution provides a contract broker, which is a central repository to store and organize contracts, and it can be integrated into your CI/CD pipeline. Brokers are great because they can also enable some more advanced features like deployment awareness, which is something that we wanted because it can quickly identify the contracts that matter when you want to deploy to a particular environment. And we'll hear more about that in a moment. The broker, so in terms of these two solutions, the broker is really Pactflow's strength. It provides a great, fully featured interface that you can manage the whole, testing workflow, view contracts, integrate it into CI/CD, all that. Specmatic, on the other hand, does not provide a broker at all. And so it relies on you to bring your own solution in terms of, storing, organizing your contracts, distributing them. Here, a lot of people might use a version control system like Git or GitHub to do that. But not having that, dedicated broker for the task really limits you from, precludes you from having those advanced features that we wanted. Lastly, the contract testing landscape is very diverse in terms of the licensing models, and existing solutions range from subscription managed services to ones that are fully open source and self-hosted as relevant. As far as the two we've been looking at, Pactflow's broker, we like Pactflow's broker, but felt limited by it being a closed source managed software as a service. Specmatic, on the other hand, is open source, which we liked. And we also liked its approach to generating the contracts, but we really missed, many of the features that a broker could provide. So ultimately, where we landed was that neither of these services provided the combination of trade-offs that we were looking for, so we decided to build our own. So now it's my pleasure to hand it off to Hernando to tell you about it.
Great, thanks, Mike. Today, I'm excited to introduce Signet. Signet is an open source, self-hosted framework for spec-driven contract testing of microservices. It's designed to assist companies facing challenges with integration and end-to-end testing. Getting started with Signet is easy and comes with minimal upfront costs since it removes the necessity of creating new unit tests. One of its core functionalities addresses a fundamental question that many development teams face, which is, will deploying this new service version cause any issues? Signet helps ensure deployment goes smoothly. Let's now get into the features of what sets Signet apart. As Mike already mentioned, only a handful of tools adopt a spec-driven approach. In spec-driven contract testing, the API spec is established independently from the implementation of either service. This often involves a preliminary agreement between the consumer and provider teams on the API spec before either service begins its implementation. Using spec-driven contract testing allows each team to conduct integration testing independently, without the need for support from others, thereby achieving greater deployability. Aligning each service with specified requirements speeds up the development process, allowing companies to rapidly deliver new service and updates, new features and updates. Here we compare Signet with two well-known spec-driven solutions currently available in the market that we've already discussed, Packflow and Specmatic. While Packflow features a dedicated broker for contract management, it isn't straightforward to adopt or open source. On the other hand, Specmatic is easy to adopt and open source, but it lacks a contract broker. Signet offers a unique blend of features. It's spec-driven, open source, easy to adopt, and comes equipped with a dedicated broker. Let's delve deeper into the remaining features and explore the significance within the contract testing workflow. Let's begin with ease of adoption. On the consumer side, Signet provides the capability to utilize existing service tests for the automatic generation of consumer contracts. Automatic contract generation offers the advantage of sparing developers from the time-consuming and error-prone processes of writing new unit tests to get started with contract testing. This efficient process makes it easier to adopt contract testing and improves the overall development workflow. Now let's turn our attention to the provider side, where Signet introduces provider verification. In contrast to alternative spec-driven solutions that require companies to develop their own tools, Signet incorporates this functionality right out of the box. Signet generates tests from the API spec to ensure the provider accurately implements the specification. Finally, teams can also effortlessly deploy the Signet broker within their current AWS cloud environment through a single command. The Signet CLI efficiently coordinates the setup of an ECS Fargate cluster, encompassing all necessary foundational infrastructure. This approach not only streamlines Signet's setup, but also provides the flexibility to scale its capacity in response to changing requirements. At the core of the application, and the next feature we'll discuss, is Signet's dedicated broker, which includes functionalities that are purpose-built for contract testing. Rather than storing contracts in version control systems, Signet employs a dedicated broker as a central contract repository. The Signet broker instantly conducts automatic comparisons between contracts and specifications upon publication, offering immediate feedback on compatibility. This automation is great. However, it's not enough to simply ensure that a service complies with a contract. What truly matters to developers is whether any disruptions will occur when deploying a new service version into an environment. This would require the additional step of identifying the current relevant set of contracts, which can be a potentially cumbersome task often left to developers in other solutions. This is why Signet's Deploy Guard feature was built. Deploy Guard oversees the deployment of service versions, offering a convenient way to evaluate the safety of introducing a new service. It validates the existence and compatibility of all provider services within the environment, ensuring that the service won't cause any disruptions for dependent consumers. What's great is that Deploy Guard is also available through the CLI, so CI/CD can gate deployments based on what's currently deployed. Deploy Guard is not the only feature that's available to be used by CI/CD pipelines. The entire contract testing workflow can be automated by CI/CD through the use of Signet CLI and webhooks. Teams can also utilize the Signet web interface to subscribe their CI/CD pipeline for webhooks pertaining to specific events, which can include new contract publications, provider verifications against API specs, and the availability of fresh contract test results. Signet's features were thoughtfully crafted to accomplish the goal of streamlining contract testing integration for companies with growing microservice environments. Since we're now familiar with what Signet is and its core functionality, I'll now pass it over to Eric to explore the engineering decisions that have influenced Signet's design.
Thanks, Hernando. First, let's talk about how Signet performs spec-driven contract testing. So Signet requires two types of documents per integration, a consumer contract and a provider specification. We can think of the contract as a representation of the consumer and the spec as a representation of the provider. Then, instead of directly checking compatibility between the consumer and provider, we can instead check for compatibility between the contract and spec. So that's the high-level overview. Now, let's talk more concretely about contracts and specs. A consumer contract represents the API interface that a consumer expects from a specific provider. If a consumer relies on multiple providers, then we require a new consumer contract for each provider. In this example, shopping cart service requires functionality A, B, and C. A and B is provided by payment service, while C is provided by inventory service. As shopping cart service depends on two different providers, we require two consumer contracts, one for each provider. On the other hand, a provider specification encapsulates the complete API interface for a specific provider. If a provider serves multiple consumers, they would all be associated with the same specification. In this example, payment service is providing functionalities A, B, and D. Payment service is serving two consumers, shopping cart service and order service, with both services being associated under the same specification. Now, we combine both of our previous examples together. In total, we have two consumers, order service and shopping cart service, as well as two providers, payment service and inventory service. Order service depends on only payment service, while shopping cart service depends on both payment service and inventory service. Keep in mind that it's possible for a service to be both a consumer and a provider. Why have a consumer contract? First off, we don't need a consumer contract to perform spec-driven contract testing. From this diagram, we see that the consumer contract is used as a middleman to test the consumer's compatibility with the provider spec. However, it's possible to cut the middleman and directly test the consumer with the spec. For instance, we can use the provider spec to generate a provider test double. We could then test if the consumer is compatible with the generated test double. If we took this approach, then we do not need a consumer contract. However, one advantage of using a consumer contract is that it allows for faster backwards compatibility checking. Backwards compatibility checking is when we test if a new spec is compatible with the same consumers that the old spec is compatible with. In this case, we know that the old spec is compatible with consumer service. We want to determine if the new spec is also compatible. First, let's examine the trivial case. In this example, the old spec provides functionality A and B, while the new spec adds on C. It's obvious that the new spec is compatible with consumer service. All we need to do is to compare the two specs and recognize that the new spec only adds on functionality. A less trivial case is when the old spec removes functionality from the new spec. In this case, functionality B is removed. This does not mean that the new spec is not backwards compatible, as it's possible that consumer service does not depend on B. In this scenario, without a consumer contract, we would have to retest consumer service against the new spec. This would entail spinning up an instance of the consumer service in a testing environment. With a consumer contract, we can test the new spec against the contract instead of the actual consumer. This test can be handled by the broker and does not require spinning up an instance of the consumer. As a result, using a consumer contract will allow us to speed up backwards compatibility testing, giving us faster feedback. Now that we covered what a consumer contract is, we'll now talk about how to generate a consumer contract. One approach is to write it by hand. Consumer contracts are serialized data files that follow a specific schema, so it's possible to manually write them using a text editor. The downside is that this can be tedious and prone to error. Another approach is to record service tests using a proxy. In this case, we assume that teams have already configured a test double for the provider, which means that during the service test, the interactions between consumer and the test double should contain the expected HTTP request and responses. Therefore, we can set up a proxy to record those interactions and then write them into the consumer contract. This approach provides a language agnostic and automatic way to generate consumer contracts. The main drawback of using a proxy is that we must wait for the service test to finish executing before we can generate the contracts. As a consequence, the contract test will be performed after the service test. Ideally, we want to perform contract tests earlier since contract tests are faster than service tests. Next, we'll switch over to the provider side and talk about how to verify that the provider adheres to the spec. One approach is to let the developer handle the testing between the provider and the spec. They can use their own testing tools to test the provider. After the test, they can then publish the test results to the broker. Although this approach offers more freedom, it increases the setup cost to contract testing. Developers would have to worry about making sure that their test doesn't drift from the latest specification. As such, we decided to bundle in a way to test the provider. Signet offers a hands-on language-agnostic approach to test the provider. First, we pull the latest spec from the broker, which prevents specification drift. Then we send a request to the provider for each request in the specification. The test is successful if all the provider responses matches with the spec. And finally, we publish the verification results to the broker. The last thing we'll talk about is how Signet integrates into the CI/CD pipeline. Signet is platform and language independent and can be run in CI/CD environments through the command line. We'll start with the workflow for the provider. First, we run provider verification to check if the provider adheres to the spec. If that passes, we run deploy guard to see if the provider is compatible with all the consumers currently deployed. Once that passes, from a contract testing perspective, we are ready to deploy. After deployment, we update the provider's deployment status. Now, we'll go over the consumer's workflow. First, we generate the contract. Then we publish the contract to the broker. To test if the contract is compatible, we run deploy guard. Once that passes, we are ready to deploy. And finally, we update the consumer's deployment status. All of these steps can be automated in CI/CD through the Signet CLI. CI/CD pipelines can also kick off contract testing workflows in response to webhooks emitted by the Signet broker. That concludes today's presentation. And now we want to take a few minutes for Q&A. If you have any questions about Signet, feel free to post them in the comments.
So while we're waiting for those to come in, Eric, can I pitch a question to you? What do you think was the most challenging part of building Signet?
I was not ready for this question, by the way.
I know. I know.
I honestly think building deploy guard was the most challenging part. One of the things that we didn't go over in the presentation because it was a bit too much details was that we allow consumer and providers to have different versions. So in the presentation, we kind of assume that there's only like one version of the provider and one version of the consumer. But in reality, the consumer can have multiple versions as they iterate, and so is the provider. And so multiple versions of the same provider can be deployed on the same environment, and same thing with the consumer. And there are a bunch of dependencies. So with deploy guard, we need to check, when I deploy a consumer, first of all, are all of my dependencies met? Does there exist at least one provider for each of the providers that I'm depending on that are deployed? And I also need to check, for all of the providers that are deployed that I'm using, am I compatible with all of them? And that type of checking just takes a bit of logic to work through and to fetch all the data for.
Well, not seeing any questions come in. I'm sort of stalling a little longer, but other than that, I think we might wrap up then. Okay. Thanks everyone for coming out. We hope you enjoyed learning about Signet. Have a great weekend. Thanks everyone.
Thank you.
Thank you.